Can you switch on that? Slowly, slowly. To discuss with the Ankit sir, and if portion is on par means you can leave. Okay. I posted now. I didn't post. Then where is that? If it is posted, me it should be there, no? Okay, friends. So once again, very good evening. Sorry, good afternoon. Okay, so now.
Good evening, sir.
Yeah, very good afternoon.
Good afternoon, sir.
So yesterday optics completed, students. Today, next chapter, wave optics. Which optics? Wave optics. So what is the wave optics means? Ray optics is failed to explain two properties. What are they? One is interference. Other one is polarization. And what is the next? Diffraction, etc. Actually, concept of ray means what? The path of the particle of the light is called ray. So here the concept of ray completely failed in explaining these three properties. That's what Huygens is a name of scientist. He came out with the new treatment for the light is called wave optics. He treated light as a wave. For example, according to Huygens wave theorem, if you take any point source of light, every source of light will produce the spherical wavelets. What wavelets? Spherical wavelets. And the shape of this wave is depending on the shape of the source. If you take any cylindrical source of light, right? What is the source of wave? Wave also, it is in what shape? Wave shape only, no? If you drop any perpendicular line, that is representing the speed of the light or speed of the electromagnetic wave. According to Huygens also, speed of this light is 3 into how much? 10 power 8 meters per second. This source of light is called primary source of light. Primary source of light. And according to Huygens, every point on the source, every point on the wave is acting like a secondary source of light. It is also called secondary wavelet also. One example, if you see, I'm taking one point source of light. It produced one wave. Actually, it produced a spherical wave. And what is the distance traveled in t seconds of time? After t seconds, this is a position of the wave, students. I'm asking you what a distance traveled in t seconds. Distance equal to how much? Speed of the light into t seconds. So that is how much? C into t. I mean, radius of the every spherical wave is how much? C into t. As I told you, every point on the wave is acting like a secondary source of light. So that also will produce some tiny wavelets like this. If you join all of them, again, we will get the new position of the wave. So what is the distance traveled by the wave in t seconds? Now also how much? C into t seconds. So within the t seconds time, the wave will travel from first position to second position. Here also what a distance traveled by wave here? Product of C into T. If you have right now in our classroom, LED source of lights are there, no? They are square in shape. What kind of wavelets they will produce? They will also produce the plane waves. What I'm trying to say, the shape of the wave depends on the shape of the source of light. Is my point clear? So now, very immediately, I will explain how this wave concept is helped to explain the concept of interference. What is that, students? Interference of light. So as an ordinary human being, kindly answer. Here one source of light is there. Here one source of light is there. And one wall or one screen is kept here. What do you expect on the wall or screen? Huh? What do you expect? You have taken two torchlights in your hand. You focused on the wall or screen. What do you expect? I am asking you. Huh? Reflection. On the wall, you can expect two bright spots. How
Yes,
many
sir.
bright spots?
Two bright
Two
spots.
bright spots as an ordinary human being. But in reality, what will happen? Instead of two bright bands, many alternative bright bands and with equal intensities can be seen, students, here in reality. Are you understanding? If you think by the concept of ray, by using particle nature, every human being will expect two bright spots. But in ground reality, what is happening? Alternative bright bands you will see. I mean, the light is distributed with equal intensities. So that distribution of the light with equal intensity is only called what here? Interference of light. How will you define interference of light? The equal distribution of the light. The equal distribution of light intensity. Of light intensity . is called what here? Interference. Understood, student? Why? Because this wave is interfered by this wave, and the first wave also interfered the second wave. Second wave also interfering. Interfering means what? When you are doing any work, someone is coming and interfering you. Will you do the task completely? Correct or not? So that a disturbance between the two light waves or more than light waves is called what here? Interference. So before learning in detail about the interference, some technical terms I must introduce, students. One important thing, students, 100% one question is damn sure today. Maybe sometimes if your luck is good means 2-3 questions also will come. Are understanding? That much deserved concept, student. Interference of light. Because it is very small chapter but powerful chapter. Okay. Out of 4-5 topics, this interference of light only large scope to get the questions. And easy also, but some confusion will come. To clear that confusion, some technical terms I have to introduce. So kindly listen carefully. And first one is path difference or path. See, this is a source of light 1. This is source of light 2. This is one screen I kept. These two sources of lights are called what here? Coherent source of light. What the name of that? Coherent. Coherent means what? Co means same. Herent means what? Same, hereditary. Mean from same source. This is yellow means this is also yellow color. This is red means this is also red. This is how much frequencies are. This is also same frequency. Now tell me what is the meaning of the coherent sources? The two light sources which they have same frequency. Same frequency is called what here, students? Tell me. Coherent source of light. Maybe exactly same or maybe slightly different also, no problem. Such type of source of lights are called what here? Coherent source of light. Now, this is one source of light. This is one source of light. In our laboratory, generally, we use a sodium source of light. Some sodium vapor suspended in the electric field. When it is excited, it will release what kind of light? Yellow color light. Now, when you use mercury vapor lamp means white light it will produce. White light means what? Mixture of 7 colors. I want to investigate one particular point P, students. So the distance between S1 and P. If you switch on the source of light S1, the every light wave will travel S1P distance only, no? That is called path travel by the first light wave. Then if you switch on the second source of light, what a distance between S2 and P is nothing but path travel by the second light wave. Which light wave has traveled more distance? This light wave only traveled largest distance. Means two light waves must and should have some path difference. What a path difference meaning? Tell me. Path difference between two light waves. Path difference between two light sources. How much? Tell me. What a formula? Largest path traveled by the light minus smallest path traveled. Okay. I'm requesting everyone kindly remember at your fingertips. One small question, little question, not a JW question. Just a basic testing question. Here one point P is there. Between S1 and P, I can accommodate one light wave, two light wave, 3 and 4 and 5. And between S2 and P, I can accommodate 1, 2, 3, 4, 5, 6, 7, 8. Now tell me what is the path difference between the two light waves? 3. Yeah? Path traveled by first light wave, how much students? Each wavelength is lambda. 1, 2, 3, 4, 5 means 5 lambda. Na? Every wave is denoted with this symbol, one crest and one trough. But a path traveled by first light wave is 5 lambda. But a path traveled by second light wave, 8 lambda. Why? 1, 2, 3, 4, 5, 6, 7, 8. 8 waves you can accommodate. Now, what is the path difference between the two light waves? Big wavelength, big path minus small path. How much that is? 3 lambda. Understood or not understood? For suppose I told you many times, when one wave is produced, wave can be interlinked with the circular motion. No? I repeat the statement, students. Kindly try to understand. When one wave is produced within the time duration, what will happen? One particle completed one circular path, no? One revolution. No? I mean, the time taken to produce one full wave exactly equal to time taken to complete one revolution. And one length of the wave equal to nothing but the distance traveled in one full circular path. Understood or not understood? And what is the, during the one wave production, what is the angle swept by the radius? One wave is produced means, I am asking you, what is the angle rotated by this radial vector? 360 degree, na? Means I can write one statement, one wavelength equal to exactly 2 pi radian phase difference, one time period. I mean the time difference, phase difference, path difference, both can be interconnected. Na? If two waves are produced means, how many degrees of angle it can rotate? 4 pi. What a time taken? 2t. If 10 waves produced means 20 pi and 20 into t. Means, sir, this is 40 pi. 10 waves produced means 10 lambda, 20 pi, very good, 10 into t. You are understanding the relation. Means, if you take any two light waves, this is the first light wave, second light wave, you notice that path difference is directly proportional to phase difference, and phase difference is directly proportional to time difference also. Kindly say yes or no. I mean, which light will reach very quickly? This light wave only reaches very quickly. It will take some more time now. So between any two light waves, there is some path gap. I mean, path difference is there, some time difference also there, and some phase difference also there. That relation I have written like this. And to remove the proportional constant, what I have to keep? Constant. So shall I write delta by lambda equal to phase difference by what a maximum phase difference in one revolution? 2 pi, 360 degree only, na? Says or no? And time difference between the two light waves equal to time difference in one revolution, na? How much that is? Capital T. It's a very, very powerful formula, students. Everyone I am requesting kindly to remember at your fingertips. Direct applications we are going to use. One small practice problem, you just answer. This is one source of light. This is one source of light S2. Here one midpoint P is there. Find the path difference between the two light waves who are reaching point P. And all are coherent sources. Throughout the wave optics, we will use only coherent source only. Zero, very good. Why zero? Midpoint, na? Very good. Here, how much path it will travel? Here also, same path it will travel. What is the path difference then? Delta minus delta, zero. Then what is the phase difference between them? Use this formula. What is the phase difference formula? 2 pi into delta by lambda. Delta substitute. So phase difference also 0. Similarly, time difference also how much? 0. Now, one more problem. Kindly work out. This is a source of light S1. This is a source of light S2. There is one point P is there. Between S1 and P, 2 waves can be accommodated. But between S2 and P, 1, 2, 3, 4, 5, 6. Now find path difference, everyone. Find phase difference between two light waves. And find time difference between the two light waves. Tell me. 4 lambda. Very good. Next. 8 pi. What a path difference? 4 lambda. Phase difference? Okay. Let me check. What a path traveled by the first light wave? 1, 2, no? What a path traveled by second light wave? 1, 2, 3, 4, 5, and 6. So what a path difference? 6 lambda minus 2 lambda. So the path difference between the two light waves how much? 4 lambda. And what is the phase difference formula? 2 pi into path difference by lambda. Substitute what a path difference value? 4 lambda by lambda. Lambda cancels out. So 8 into pi. And what a time difference between the two light waves? From this formula, T into path difference by lambda. Delta value how much? 4 lambda by lambda. Lambda katam 40. This is a very important skill, students. Finding path difference between the two light waves and phase difference, time difference is very important. Okay, now very immediately we'll move to one very famous experiment that is called Young's double slit experiment. Without this question, your J will be not exist. So Young's double slit experiment. Because this is the only topic have wonderful applications. So definitely question setter love to give the questions. Okay, from the Young's double slit experiment, and easy also. It is also called interference experiment. Interference experiment, or very simple abbreviation is there, YDSE experiment. YDSE means Young's double slit experiment. First, let me introduce the apparatus. Same, nothing is there. He has taken one cardboard. Young is a scientist. He has taken one cardboard. What he did? He made 2 holes. One hole and another hole. These 2 holes are acting like a coherent source of light. Coherent means what? They are acting like a same frequency source of light. Behind the cardboard, one real primary source of light is there. As I told you, these two holes are acting like a secondary source of light. One is S1 and other one is what here? S2. And what a distance between the two sources? Let's say small d. I am keeping one screen here. Let's say the distance between the screen and plane of slit how much? Capital D. Usually I am using a source of light as a sodium lamp. What is the color of the sodium lamp? Yellow color. Mercury means white. Mercury means what here? White light. And sodium means what? Yellow color. And some light rays will fall on S1. I want to investigate. Actually, I told you these two light waves, what will happen? They will interfere each other. As a result, on the screen, what do you notice? Anyone will expect two bright spots, na? With our knowledge, oh, two sources of lights are there. On the wall also, two bright spots should come. But actually, many number of bright spots and dark spots you can see like this. One bright band. This is a first bright band. This is also first bright band. This is a second bright band. This is also second bright band. Like that, alternative bright bands and dark bands are seen. Such phenomena only we called what here? Interference. So now we have to investigate why that light intensity equally distributing. We have to investigate. I'll take one point P. What I will do? I will take one point P. How many probabilities are there on the point P? Two probabilities. One bright band may be formed and other one dark band may be formed. Okay. So when light waves are interfering, this is a first light wave and this is a second light wave is interfering. Shall I write first light wave equation like this? Y1 equal to A1 into sine omega t. Every light wave is given this equation. A1 is called amplitude of that light wave. Omega is nothing but what here? Angular frequency of that light wave. And what is the second wave can be given? Y2 is equal to A2 into sine omega t plus pi. There is some phase differences there or not? In the previous case only, we found how much phase difference? Definitely, if that is not symmetrical point means less or more some phase difference taking place. Yes or no? This is omega t plus 0 means shall I use vector method or phasor method? With x-axis, how much angle it is making? A1 vector, 0 angle only making, na? Kindly say yes or no. Next, this vector, how much angle it is making? Plus pi, means like this. What is the angle between them? Pi. So, two waves will mix, means interfere. It will get resultant wave, na? What resultant wave? Y1 plus Y2. If you use parallelogram law vector addition, what is resultant amplitude representing? The diagonal only representing resultant amplitude na. Who will tell resultant amplitude formula?
A1 plus
Shabash. Under root of how much? A1 square plus A2 square plus 2A1 A2 into cosine of pi. If you squaring on both sides, what do you get? AR square equal to A1 square plus A2 square plus 2A1 A2 into cosine of pi. In your 11th standard, you might be, I only told, you might be heard also in your school, that intensity of the light equal to how much? K times any proportional constant into amplitude, say amplitude square. Means resultant amplitude whole square I can write. Resultant intensity by K I can write, no? A1 square I1 by K. I1 is the intensity of the first light wave. I2 is what here? Intensity of the second light wave. But A2 square value? I2 by K2. Sorry, same proportional constant. Proportional constants will not alter. So I will write K only. 2 into A1 value, how much respond? Root of I1 by K. A2 value, how much? Root of I2 by K. And into cosine of pi. K cancels out. So what is intensity of the resultant wave? I is equal to I1 plus I2 plus 2 under root of I1 I2 into cosine pi. I'm requesting all kindly remember at your fingertips.
Yes, sir.
Very powerful equation. There is no rule that two intensities of the lights should be different. If the sizes of the two holes are same means intensity is also same, na? Correct or not? I will add on that point. If size of the two holes are same, if size of two holes are same, intensities also must be equal. Now I2 equal to I1 equal to how much? I0. If you substitute, what resultant intensity? I0 plus 2 under root of I0 whole square into cosine pi. I0 plus I0 how much? Sorry, 2 I swallowed here. I will add. I0 plus I0 how much? 2 I0 plus 2 I0 into cosine of pi. 2 I0 if you take outside 1 plus cosine pi. You know everyone on formula. Cosine 2 theta equal to how much? 2 cosine square theta minus 1. You substitute this formula here. What do you get the intensity? I is equal to 2 I0 bracket will start 1 plus 2 cosine square pi by 2 minus 1. Plus 1 minus 1 cancels out. So what intensity of the resultant wave when two identical waves are interfering? 4 I0 into cosine square pi by 2. Two formula you have to remember at your photographic memory. One is for unidentical holes, other one for identical holes. Okay. Now I'm requesting you all watch the intensity. On what factor it depends? Only phase difference, no? Because I0 is constant depending on one and only one function. So intensity of the light or resultant wave depending on function of pi only, no? Correct or not? As I told you here, bright band is formed means what? Intensity will be compulsory maximum. Here dark band is formed means intensity will be how much? Compulsory minimum. Now tell me the condition for maxima. Function? Greater. Can you repeat that statement?
Intensity of light is equal to
Function pi.
it should be greater for maximum and less than
Very good, very good. Correct only. So means to make the intensity maximum means this cosine square pi by 2 should be maximum. Yes or no? Means here also you can take this cosine pi value how much compulsory? Maximum. Maximum means what? Plus 1 only. No? I will not take this one. I will take this one. Because this is application, one specific case only. But this is the theoretical formula. So to make this intensity maximum, it's compulsory cosine pi should be maximum. I will write down that point. To make intensity maximum, what the value of cosine pi should be compulsory? +1. For what phase difference values cosine is 0? Sorry, cosine 0 is 1. Pi is equal to 0. Next 2 pi, 4 pi, 6 pi, and so on like that. Na? Keep on going. Means finally 2n pi will come. Where n value start from? 0, 1, 2, 3, and so on. Means I can generalize. What I can generalize here? If phase difference is 0 means what? That is called 0th maxima. What the name of the maxima? 0th maxima, or it is also called which maxima? Central maxima. If pi equal to 1, if pi equal to 2 pi means what? First maxima. Means if you see the scenario, two source of lights are there. This is what 0th maxima. This is what here? First maxima. Here also one more first maxima is there. This is one second maxima. This is one second maxima is there. Middle one is called what here? 0th maxima or central maxima. If pi equal to 4 pi means what type of maxima that is? Second maximum. Okay. If you see the condition strands for 0th maxima, what are the conditions? Tell me. What is the phase difference must and should be? 0. Phase difference 0 means what a path difference formula? Lambda into pi by 2 pi na? Substitute here. So path difference also 0. But time difference? T into time difference by capital T. No, wait a second. Time difference is nothing but what? Time period into delta by lambda. Na? So delta value if you put this also 0. Similarly for first maxima, what are all these parameters? Write the conditions. I'm requesting all write all conditions for first maxima and second maxima. First maxima, na? First maximum phase difference how much? First maximum phase difference how much, friends? Here already wrote 2 pi only, na? What is the path difference? Formula lambda into pi by 2 pi, no? So substitute pi value how much? 2 pi. So delta equal to how much? Lambda. Correct or not? Similarly for nth maxima, n lambda. For nth maxima, what is the condition? N lambda. I'm requesting all kindly remember, students. Your n value should not start from 1, 0, 1, 2, and so on. Understood or not understood? For phase difference, how much for nth maxima? How much? 2n pi, no? 0, 2 pi, 4 pi means what? 2n pi I can write. Correct or not? That is the condition for what here? Phase difference. Here also where n value will start? 0, 1, 2, 3 and so on. And what is the time difference between the two light waves formula? T into delta by lambda. Delta value how much? N lambda by lambda. Lambda cancels out. The time difference between the two light waves to form nth maxima? N into T. What is the intensity of the maximum formula? What intensity of maxima? If two unidentical holes means what the formula I equal to? Very good. I1 plus I2 plus 2 under root of I1 I2. Cosine pi value plus 1 dana. So what a maximum intensity? I1 value how much? Root I1 whole square plus root I2 whole square plus 2 under root of I1 I2. So what a maximum intensity equal to? Root I1 plus root 2 I2 whole square. I am requesting you all to remember. If it is for identical holes means what? These are unidentical sources. For identical sources, what a formula? Very good. For identical source of light, this formula is there. Now I is equal to where? 4I0 cosine square pi by 2. Pi value you should put 0 only. Na? Means 4I0 will come. So for identical source of light, what is the maximum intensity? 4I0. That is the reason for all bright bands, the intensity divided into equal intensities. What is the every intensity here equal to 4 into I0. Understood? So I am requesting to remember all these conditions for maxima. Such interference is called what here? Constructive interference. So what are the conditions for constructive interference? Delta equal to how much? N lambda. Phase difference how much? 2n pi, and time difference how much? N into T. Okay. 2 minutes. I will have some water and copy this. If it is possible, you reduce destructive interference. Okay, so I hope you all understood the constructive interference. Huh? Now, formation of minima. What is that? Formation of minima. What is another name of minima? Respond. Dark band also. Formation of dark band. That interference is what here? Destructive interference. Destructive interference. Destructive interference means, see the intensity formula how much? I1 plus I2 plus 2 under root of how much? I1 I2 into cosine of pi. What is the concept of dark band? The region where there is a absence of light. Correct or not? That is called what here? Respond. Minimum intensity. No. When intensity is minimum, when cosine pi is minimum. Correct or not? I will write down that point. If cosine pi is minimum, means -1, don't think that 0, then only what will happen? Intensity is getting minimized. Yes or no? Now tell me and guide me, what are the possible values, students? Pi is equal to pi and
Even odd pi.
yeah, odd pi's, 3 pi, yeah, correct, and so on up to 2n plus 1 pi. 2 are correct. If you are using phase difference, 2n plus 1 into pi means n value should start from 0, 1, 2, 3 and so on. Now if you don't like this,
2n minus 1 means
because here this is a confusion will come. You are talking 0th maximum means 0 only you have to use. But when you are using 2n minus 1 into pi, n value should start from 1, 2, 3, so on. This I will not take. Why? Confusion will come. Why confusion will come? I am talking 0th maxima, but I am putting 1. Big confusion will come, no? Yes or no? That's what I will use this only. No, sir, I like this only means that is your choice. But if you alert to that point, it's well and good. Here n equal to 1 means which maxima? Sorry, here minimum we are talking, na? This is the first minima, na? Here 0 means what? 0th minima sounds. But so it creates lot of confusion. So what I will take throughout my lecture, I will take pi is equal to how much? 2n minus pi into 2n minus 1 into pi only I will take. Means n equal to 1 means everyone easily can understand first minima. But here 0 will come, no? Number you are using 0, but first minima you are telling, no? So confusion will start. So I will take 2n minus 1 into pi. N equal to 2 means what? Which minima? Respond. Second minima and so on. Correct or not? Then what is the path difference to form nth minima? To form nth minima, what is the path difference formula? Who will tell path difference formula? lambda into phase difference by 2 pi. Yes or no? Pi value substitute here. So what is the path difference between the two light waves to form nth minima? Lambda into how much? 2n minus 1 into pi divided by 2 pi. Pi cancels out. What a path difference equal to 2n minus 1 into lambda by 2. So star mark means I am requesting you all to kindly remember at your fingertips. And n equal to where it will start 1, 2, 3 and. And what a time difference between the two light waves? What a time difference between the two light waves to form nth minima? Who will tell formula time difference equal to capital T into path difference by lambda t only. Path difference how much? 2n minus 1 into pi whole divided by lambda. Sorry, 2n minus 1 lambda by lambda. No? Yes. Lambda cancels out. But a time difference 2n minus 1 into t by 2. So what are the conditions? At a glance, I will write to form nth minima. To form nth minima, what are the conditions? Tell me. Delta must be equal to how much? 2n minus 1 lambda by 2. What is the phase difference between them? Very good. 2n minus 1 into pi. And time difference how much? Very good. 2n minus 1 into capital T by 2. I am requesting all kindly to keep all these stuffs in your photographic memory. Why? Because in the future you will understand direct questions will come in your JW. Is my point clear? Huh? Okay. Then what is the intensity of this dark band when you are using unidentical sources? Unidentical sources when you are using. What is the formula for minimum intensity? Full tell formula I1 plus I2 plus how much? 2 under root of I1 I2 into minus 1 cosine phi value. So then intensity gets a minimum. So minimum intensity is nothing but what here? Root I1 whole square plus root I2 whole square plus minus 2 under root of I1 I2. Correct or not? So what the minimum intensity is nothing but root of I1 minus root of I2 whole square. This is called what here? Minimum intensity. Yes or no? Is there any rule that two sources should be identical? No. Sometimes identical also. So if identical sources are there, identical sources means what? Same size. If identical sources means what is the formula? 4I0 into cosine square of pi by 2. Pi value what I should put? Pi value what ma? First, where is the first pi value? Pi only, no? 0 you will get. No. 0 you will get. If you are using identical sources means first pi value how much? Pi you have to put. Pi by 2 means what? Cosine 90. Na? How much that is? 0. That is a very, very important point, student. When you are using unidentical source of light, dark band completely not dark. Some light present, no? But identical sources when you are using, completely light is escaping, students. Understanding or not understanding? So that point alone you have to remember at your fingertips. Okay. And some more conditions. Path difference between the two light waves. Path difference. Formula. As I told you in the YDSC setup, I have taken one cardboard, 2 holes I pierced. This is source S1. This is source S2. Behind one source of light is there. What is this? One screen. Only I am analyzing at particular point P. This is another wave, first wave, and what is this? Second wave. Yes or no? Now, tell me, what is the path difference between the two light waves? From the midpoint, if you join the point P, and with the horizontal line, if it is making some angle theta, the distance between them is small d. If you draw any perpendicular line, this is theta means this is also theta, no? This is d means this is d cosine theta. This is what here? D sine theta. Not understood, no? Once again, I will draw somewhat magnified view. This is source of light S1. This source of light S2. What is the distance between them? D meter. There is one point P is there. I will join one line. I will join one line. If you drop one perpendicular line, this is only the extra path traveled by the object, no? Says or no? This is D means, this is theta means, this is D cosine theta, this is D sine theta only, no? Says or no? So now tell me what is the path difference between the two light waves? Path difference. Delta equal to how much? D into sine of theta. This is our screen. This is our midpoint P. And this is also angle theta. At point P, how many probabilities are there? Two probabilities. One is nth maxima or nth minima may be possible. So what are distance between the center and the point P? Yn, no? Every distance should be measured from the center of the screen. I told now, without a frame of reference, without your origin, no max analysis can be done. Here all distances, how you can measure? From center of the screen. Yn is nothing but distance between the center of the screen and the point P. Understood or not understood? So I can write sin theta equal to how much? For all small angles, with your permission, shall I write tan theta? I told many times, if the angles are very little, that equal to how much? Sin 0 I can write, and also tan 0 also I can write. What a tan theta value? Opposite side by adjacent side. Capital D. So substitute path difference between the two light waves, how much? D into tan theta. So path difference value, how much? D into tan theta formula? Yn by capital D. It is also very, very important formula, student. I am requesting all to remember in your photographic memory. Direct questions will come. For suppose, at point P, if nth maxima is there, case 1, at point P, if which maxima is there? Nth maxima is there. So I can write delta equal to what is the formula? N lambda only na for condition. Delta formula how much, friends? Just now we got it. How much? D into Yn divided by capital D equal to N lambda. So what is the distance between the nth maxima and center? How much? N lambda D divided by small d. This also I am requesting, it's full memory only, students, wave optics. So this is the distance between what and what? Nth maxima and center of the screen. Okay. Then now we can analyze the distance between first maxima and everything. This is a source of light S1. This is a source of light S2. This is a screen. Then where central maxima is formed? For central maxima, n value how much, friends?
0.
Very good. For central maxima, n value 0 means y0 also 0, no? What is the distance of first maxima? First maxima how much? N value what I should put? 1. So what are distance? Lambda d divided by d. Means this is a 0th maxima. This is what maxima? First maxima. What are distance between them? Lambda d divided by d. What are distance of the second maxima? How much n value? How much I have to put? 2. So what are distance between the second maxima and center? 2 lambda d divided by small d. Correct or not? This is n equal to how much? 2. What is the distance between the central maxima and second maxima? 2 lambda d divided by 2. 2 lambda d divided by d, sorry. What is the distance between the two successive bright band is called bandwidth. How we can define bandwidth? Bandwidth is nothing but what here? Distance between the two successive bright bands. I mean, either y2 minus y1 or y3 minus y2 or y4 minus y3, whatever. You substitute y2 value how much? 2 lambda d divided by small d minus lambda d divided by small d. So what is the formula for bandwidth? Lambda capital D divided by small d. I am requesting everyone to remember this formula also at your fingertips. Means one important application, students. Full YDSC setup I filled with some water. What will happen to bandwidth? This is the Young's double slit experiment. Completely I filled with water. What refractive index of the water? 4/3. What a new bandwidth? New bandwidth formula how much? Lambda new wavelength by capital D small d. Na? When light enters into denser medium, what a new wavelength will become? Lambda by mu, no? Lambda prime value, how much I should substitute? Lambda capital D divided by small d and into mu. Mu value how much here? 4/3. So substitute here. So what a new bandwidth? Lambda d divided by d and how much? 4/3. So this is a new bandwidth. It will decrease. Understood? Earlier it is lambda d by d means what? Now it will become how much percentage? Just 75% of the original bandwidth. Now case number 2, minima. At point P, if nth minima is formed, which minima? If nth minima is formed, what is the condition for path difference? Who will tell the formula? 2n minus 1 into lambda by 2. When you touch this equation, n value should start from where to where? Not 0, students. 1, 2, 3 and so on. What is the condition for path difference? Delta formula how much? dyn by capital D equal to 2n minus 1 and lambda by 2. So what is the distance between center and nth maxima? 2n minus 1 into lambda by 2 and into small d. This is the distance between center and nth maxima. think this week teaching topics completed. Young's double slit experiment, positions of maximum and minimum over. Okay, students. Okay, so I think that's all today. Now we will meet in the next session, students. Thank you.